Good noon, everyone, and welcome to the first lab of PPS subject here. Look, this is your first lab. We haven't gotten chance to meet earlier in a lab session, right? So let me give you a few instructions, some basics. How are we going to follow in the lab sessions, and some basic instructions related to your program submissions and all. And then we'll move forward for not for the first practical directly, because I'll show you the first practical is all about C program, and we haven't started C program yet in the lecture sessions. So we are not in a position to write any program at this present time. So we will go for the unit 1 memory, CPU, and all those understanding part. Okay. So that's what I plan. So let me go through the multiple points here. Now, if you look at the syllabus here, and if you scroll down and go to the program list or the practical list of experiments, then as you can see, you have the first program which makes basic calculations like addition, multiplication, and so on. Now you need to write a program, which is not possible for the first lab. What exactly we do here is until we have started C programming language in lecture sessions, till that time, we actually demonstrate the real CPU unit or the CPU cabinet. We open and we show that hardwares, each and every hardwares physically we show to the students. Now that's possible in physical lab sessions if lab sessions are happening physically here. As long as we are in an online mode right now, what we will do is I'm going to give you the YouTube video link, and I'll give you time to have a look at that video. Those videos will be around 3 to 5 minutes videos only. So you go through those videos, and then we will discuss what everyone has understood and what that video is about to convey the message. Okay, so that's what we will do today. We will have a look at some of the videos, the let's say knowledgeable videos, to understand how computer works or how hard disk works, what is memory, and why we need memory, and so on. Okay. But before we start that, look, we have been given a list of programs which we are going to perform in a lab session. Then what I want is you perform this program on your PC or laptop or even in a mobile. I'll show you how you can do your programs online, because there are a number of online C compilers. So there are a number of websites where we can go and write our C program and execute that C program in a browser only. So if you are using your mobile to join this meeting, still you will be able to write your programs and execute those programs. Okay. So it's not necessary that you need to have a system, you need to have a laptop or anything. It's not necessary. You can write your programs using mobile. Even you can execute those programs and have a look at the output. So first you perform those programs. Then how are you going to submit those programs? I'm going to create a Google Classroom, and I'm going to send you the invitation. In the next week, I'll do that thing. Okay, so you will receive an invitation email. You just need to accept that invitation by clicking on a button inside your email, and you will be the part of that classroom. Now, inside that Google Classroom, I'm going to generate some of the assignments where you need to upload your programs. That's how we are going to have submissions. Now, what program you need to upload or how you need to upload? So once you are done with the practical thing, once you are done with writing your program and you run that program, you have the perfect output. After that, you have to write that program in a page, pen and paper. Use pen, paper, write that entire program in a page. Now that can be a simple page, or you can create your book if you require. Now that's your choice. You write your program in a file page or a simple page, or you prepare entire book. That's your choice. What I want is you write your program. Below that program, you write your output, handwritten program, handwritten output on a page. Then you scan that page, convert it to PDF, and upload that PDF inside the Google Classroom assignment. That will be your process. Let me clarify one more time. आप पहले ये प्रोग्राम परफॉर्म करोगे. व्हेन वी स्टार्ट, जब हम चालू करते हैं, आप क्या करोगे? पहले आप अपना प्रोग्राम लिखोगे, उसे एग्जीक्यूट करोगे, आउटपुट चेक करोगे. इफ एवरीथिंग वर्क्स प्रॉपरली, देन आप वही प्रोग्राम को हैंड रिटन एक पेज में या एक बुक में लिखोगे. पहले प्रोग्राम लिखो, उसके नीचे उसका आउटपुट लिखो. आफ्टर दैट आप उसका फोटोग्राफ लोगे या स्कैन करोगे एनी हाउ, एंड यू आर गोइंग टू कन्वर्ट इट टू PDF. अब वो PDF जो है वो आपको गूगल क्लासरूम में अपलोड करना होगा. Now you might be thinking कि सर इतना लंबा प्रोसेस क्यों करवा रहे हो? Once we have written that code properly and that is being executed perfectly, then what is the need of writing that program in a page? So being a GTU student, at the end of the semester, you have to appear for handwritten exam. And in that exam, GTU is asking number of programs, okay? GTU is asking number of programs in the end semester exam. तो फाइनल एग्जाम जब आप लिख रहे होगे आंसर शीट के अंदर, तब आपको कोई IDE या कोई एडिटर नहीं मिलने वाला प्रोग्राम करने के लिए. आप दिमाग से सोचोगे, हाथ से लिखोगे. And that practice I want you to have from the starting of this semester. मुझे वो प्रैक्टिस करवानी है आपके पास पहले से, कि आप वो प्रोग्राम कैसे लिखते हैं. लिखते वक्त आप सेमीकोलन ना भूल जाओ, आप डबल कॉट ना भूल जाओ, एम्परसेंड ना भूलो. इस वजह से मैं आपके पास ये सारे प्रोग्राम्स लिखवाऊंगा. ठीक है? Now Jay is asking, don't we have any software C language like look, Skype is not a software, it is editor. Okay, look, when we start C programming, at that time I'll also tell you different editors that you can use. आपको जो अच्छा लगता है आप यूज कर सकते हो. I'm not going to forcefully tell you that you need to have a blue screen turbo C. Okay, I'm not that person. जितने भी पॉसिबल वेज हैं मैं आपको बता दूंगा. आप ऑनलाइन भी कर सकते हो, आप अपना सॉफ्टवेयर इंस्टॉल कर सकते हो, आप दूसरा कोई भी एडिटर यूज कर सकते हो. I'll tell you all those options. Then whatever you feel comfortable, आप उसको फॉलो कर सकते हो. Fine. So Jay, you can use Skype if you want, or if you want other software, you can also use that thing. Eclipse भी यूज कर सकते हो, कोड ब्लॉक भी यूज कर सकते हो, टर्बो सी इम्यूलेटर भी यूज कर सकते हो, ऑनलाइन वेबसाइट भी कर सकते हो, विजुअल स्टूडियो भी यूज कर सकते हो विथ एक्सटेंशंस. एवरीथिंग इज पॉसिबल. The aim is we want to learn C programming language. अब वो सीखने के लिए आपने कौन सा एडिटर यूज किया, that doesn't matter. And as I say, when we start C, I'm going to tell you all those things. Today we are not going to start that thing, so let's keep it aside. Yeah, so we are talking about submission process. आप पहले ये प्रोग्राम बनाओगे, एग्जीक्यूट करोगे, सही आउटपुट मिलने के बाद पेज या फाइल पेज या बुक में लिखोगे, स्कैन दैट थिंग, कन्वर्ट इट टू PDF. वो PDF गूगल क्लासरूम में अपलोड करना होगा. That's how I'm going to have your submissions. Follow all the deadlines. Okay, follow all the deadlines that I provide in the Google Classroom. अगर आपने डेडलाइन फॉलो नहीं की, योर मार्क्स विल बी कट. अगर आपने प्रोग्राम सही नहीं लिखा, आपके मार्क्स कट होंगे. अगर आपने आउटपुट परफेक्ट नहीं लिखा, आपके मार्क्स कट होंगे. सो बी केयरफुल व्हेन यू आर राइटिंग योर प्रोग्राम इन अ पेज और इन अ बुक. Well, so that's how we are going to follow all these experiments. But as long as we have not started C programming language till now, so agar hum apna syllabus dekhe, then the first unit is all about introduction part of the computer programming. From unit number 2, we can start C. So in this part, as I say, अगर फिजिकल लैब होती तो हम यहाँ पे पूरा CPU कैबिनेट ओपन करके सबको दिखाते थे. दिस इज द मदरबोर्ड, दिस इज द हार्ड डिस्क, दिस इज द रैम, this is how it works and all those things. Now, as long as we do have online sessions right now, we are going to follow the same thing but in a different manner. मैं आपको YouTube की एक लिंक दूंगा, आप वो वीडियो देखोगे. After watching that video, we'll have a discussion part here in this meeting. So no one is going to leave this meeting. Keep it as it is. वीडियो में भी प्ले कर सकता हूँ, लेकिन बिकॉज ऑफ इंटरनेट कनेक्शन कुछ स्टूडेंट्स को वीडियो पहले ऑडियो बाद में आएगा या मिसमैच प्रॉब्लम्स होंगे because of bandwidth. That's why I'm not going to play that video. I'll give you the link. I'll play that video here but in a muted way. Well, so that's how we will follow, and we'll understand how hard disk works, what is SSD, how it is built, what is RAM, how computer works and all. तो हम ये चीज जो है आज फॉलो करने वाले हैं. Okay. Prince Kumar is saying I'm install VS Code and GCC. Well, that will also work. If you are comfortable with VS Code, go for it. आज के लिए कोई प्रोग्राम नहीं, आज सिर्फ समझना है हमें. Fine. So let me give you the first link. Have a look at your chat box. Follow that link and see that video.
That often act as extensions of ourselves. Memory plays much the same role, whether it's a Everything in a computer's memory takes the form of basic units called bits, or binary digits. Each of these is stored in a memory cell that can switch between two states for two possible values, 0 and 1. Files and programs consist of millions of these bits, all processed in the central process.
Okay now? Yeah, that's Priyanshu. That's why I told you I'm not going to play the video and audio both because of bandwidth problem you will not hear that properly. इसी वजह से मैंने वो लिंक चैट बॉक्स में दिया है. Right? You follow that link, you have a look at that video at your place. After 5 minutes, we will discuss that video inside this Google Meet. Okay, so once you complete that video, update your status in the chat box so that we can start discussion. Yeah, great. So what you have understood from this video? What all the things that you get from this video? Just post it, or you can speak here. As long as this is a lab session, we have limited students, so you may speak if you feel it's feasible for you. Look, language is not a barrier, so don't think that I will not be able to speak in English. Speak in Gujarati, that's fine. Speak in Hindi, that's also okay. So put your thoughts here. What you have you have taken from this video. ये वीडियो खत्म होने के बाद आपको क्या याद रहा, आपने क्या समझा इससे? Okay, when it says about the speed of computer, okay. Look, when we talk about computer, it's the entire system. We have a number of different hardwares which operate in a different speed. Yeah, Jay is saying that it only understands binary language. Yeah, computer can only understand, CPU can only understand binary language, zeros and ones. The work of a computer. Memory store a binary number. Well, everything inside the computer are being communicate with zeros and ones sequences, so binary there. Okay. What else? It uses the transistor and capacitor to store the data. Yes, it makes use of transistors and capacitors to store data. DRAM and SRAM. 0 means no charge, 1 means charge. So look, we want to store binary data, either 0 or 1. Now, how can we store it? So if it is electronic device, you are going to store the charge. If there is no charge, then 0. If there is a charge, then 1. If it is electromagnetic device like hard disk, then you are going to set some north and south pole directions, and so on, right? So that's how different hardwares will store your data. SRAM and DRAM, dynamic RAM and static RAM. And then there are RAM and ROM. Yeah, random access memory, read-only memory. RAM is temporary, that's correct. Whereas hard disk, floppy disk, or maybe pen drive or CD DVDs, those are secondary devices which store your data permanently, we can say, but not exactly. Not exactly a permanent, but for a longer time. Okay. RAM is random access memory, but it is primary and it is temporary. Now, as long as you cut the power off, it will not have that current which it needs to store the data. If there is no current, then no data. So everything will be wiped out if you break your current power. Okay, so that's why RAM is a temporary. Compare RAM, it hold more for more time. Well, Venus, what you are talking about? RAM is volatile, yes, temporary memory or volatile memory, because the data in that is going to be wiped out. So anyone understood why we require RAM? And even in this video, you might have heard of cache memory. So anyone has that question, why we need it? Yeah, Jay is said speed purpose. That's correct. But What kind of speed and what is the need? RAM is faster, but even your processor is more faster than RAM. Any idea about this? Well, Pankaj is saying to store instruction. That's correct. Actually, we are going to store our program and our data in RAM. Look, when if you look at your processor configuration, then how do we measure our processor in terms of its speed in terms of gigahertz, right? When we talk about processor, we say this processor is 2.3 gigahertz, 1.5 gigahertz, and so on. So that is what the speed of your processor. Now, where is your actual data? Maybe in hard disk. Now, how do we measure the speed of hard disk? If we talk about hard disk, then the speed of hard disk is in terms of RPM, right? 7200 RPM, 4800 RPM, and so RPM, rotation per minute. So inside our hard disk, there are going to be plates, disks, which is continuously rotating, and on that we have a head which is going to read or write our data. Well, gigahertz speed is much more faster than having even 7200 RPM hard disk. Your processor can process data much more faster than your hard disk can read it or write it. Okay, हार्ड डिस्क जो स्पीड में रीड करेगा उससे काफी ज्यादा स्पीड में प्रोसेसर उसको प्रोसेस कर पाएगा. तो फिर होगा यूं कि हार्ड डिस्क धीरे रीड कर रहा है लेकिन प्रोसेसर ऐसे ही बैठा है क्योंकि उसके पास डेटा ही नहीं है. जब तक हार्ड डिस्क से डेटा नहीं आएगा तब तक प्रोसेसर बैठा रहेगा ऐसे ही. So that's the problem. We have a speed difference between processor and a hard disk. अब हार्ड डिस्क को साइड में रखो, आप सीडी की बात करोगे, then it is again सीडी या डीवीडी कैसे वर्क करते हैं, it's the same mechanism. Just डेटा जो है कोई अलग फॉर्मेट में है. हार्ड डिस्क के अंदर इलेक्ट्रोमैग्नेटिक है, सीडी के अंदर ऑप्टिकल है. बट आखिर में तो वो सीडी भी रोटेट होगी, एक लेजर बीम होगा जो ऑप्टिकल बीम जो रीड करेगा डेटा and then it is going to transfer it. चलो सीडी साइड में रखो, पेन ड्राइव वो तो इलेक्ट्रॉनिक डिवाइस है, फिर भी पेन ड्राइव की स्पीड प्रोसेसर से कम है. एट द एंड इट इज आईओ ऑपरेशन, इनपुट आउटपुट ऑपरेशन जो परफॉर्म होगा कहीं और जगह पे, नॉट इन द प्रोसेसर. तो ये जो स्पीड डिफरेंस है, आपके जितने भी हार्डवेयर हैं जहां पे आप डेटा स्टोर करते हो और जहां पे आपका प्रोसेसर है, ये दोनों के बीच का जो स्पीड डिफरेंस है वो डिफरेंस बड़ा है. नाउ टू फिल दिस गैप वी हैव अ रैम इन बिटवीन. अब अगर आपको याद हो तो अगर हार्ड डिस्क से आपने रीड किया तो वो पहले रैम में गया, रैम से प्रोसेसर में गया. अगर सीडी से आपने डेटा रीड किया तो वो डेटा रीड होगा यहाँ से, वहां से वो रैम में गया और रैम से वो प्रोसेसर में गया, एंड सो ऑन. सो व्हेनेवर यू ब्रिंग सम डेटा फ्रॉम एनी डिवाइस इट गोज टू रैम फर्स्ट और रैम से प्रोसेसर में जाएगा. Now RAM is electronic device, so it has faster speed compared to CD or DVD or hard disk or any other IO device, right? तो वो गैप कहीं ना कहीं थोड़ा फिल होता है. नाउ हाउ, एट द एंड आप तो जो डेटा रीड करोगे वो तो हार्ड डिस्क या सीडी से ही रीड होगा, लेकिन व्हाट कंप्यूटर इज गोइंग टू डू, वहां से बंच ऑफ डेटा रीड करके पहले रैम में डाल देगा वो. Now your processor can read that data from RAM. अब RAM की स्पीड ज्यादा है तो प्रोसेसर आइडियल कंडीशन में नहीं बैठेगा. प्रोसेसर को जो डेटा चाहिए वो RAM के पास से उसको जल्दी मिलेगा. So at least initially आपको टाइम लगेगा डेटा रीड करके RAM में लाने के लिए, लेकिन एक बार अगर RAM में आ गया तो प्रोसेसर उसको जल्दी प्रोसेस कर पाएगा. That's what the thought behind this, having a RAM in between. अब प्रोसेसर के पास तो एक से ज़्यादा कोर हो सकते हैं. आपका प्रोसेसर जो है वो मल्टी थ्रेडेड प्रोसेसर है, एक से ज़्यादा प्रोसेस एक साथ कर सकता है. तो अलग अलग प्रोसेस अगर कर रहे हो, सबको कोई अलग अलग डेटा चाहिए, तो वो रैम में कहीं अलग अलग जगह पे होगा. दैट्स वाई इट इज़ कॉल्ड रैम, रैंडम एक्सेस मेमोरी. वो मेमोरी तो है लेकिन उसको आप रैंडमली एक्सेस कर पाओगे. ओके, सो टू फिल दैट गैप we have a RAM. Excuse me. Well, RAM की अगर स्पीड हम देखें, RAM की कॉन्फ़िगरेशन की अगर बात करें तो RAM की भी स्पीड होती है. RAM speed is measured in terms of megahertz. Okay, 2200 megahertz, 2600 or 2800 megahertz or something, right? DDR3, DDR4, different versions of RAM. So अगेन प्रोसेसर गीगाहर्ट्ज में काम करता है, रैम जो है वो मेगाहर्ट्ज में काम करती है. स्टिल देयर इज अ गैप इन बिटवीन. अब ये गैप को फिल करने के लिए बीच में कैश मेमोरी आती है. सो दिस इज योर हार्ड डिस्क हियर. ओके, वेल ऑन द लेफ्ट साइड you can see your hard disk. On the bottom of this image somewhere here you have the RAM, and this smiley face is here in the center part is your processor. अब processor के पास cache memory होती है. If you look at the configuration of your processor, you might have seen L1 cache memory, L2 cache memory, or L3 cache memory, and so on. So L1, L2, L3, these are the different levels of cache memories. Even एक cache memory से काम नहीं बना तो हमने कैश मेमोरी के लेवल्स जनरेट कर दिए. नाउ कैश मेमोरी is a static RAM. Look, this RAM that we have on the motherboard is a DRAM, dynamic RAM. Cache memory is a static RAM, SRAM. अगर RAM की बात करें, DRAM, डायनामिक RAM की बात करें, तो वो ट्रांजिस्टर और कैपेसिटर को यूज करता है उसके अंदर डेटा रखने के लिए. मतलब जीरो, अगर वो ट्रांजिस्टर में हमने करंट सेव नहीं किया तो जीरो, अगर वो ट्रांजिस्टर के अंदर हमने करंट सेव किया देन इट बिकम्स 1. ओके, सो दैट्स हाउ वी स्टोर डेटा इन रैम, 0 और 1. अब थोड़े टाइम के लिए अगर आपको ये डेटा स्टोर करके रखना है वहाँ पे, अब ट्रांजिस्टर जो है वो मतलब लंबे टाइम के लिए वो डेटा स्टोर नहीं कर पाएगा, करंट लीक हो जाएगा वहाँ से. दैट्स वाई we need to recharge it, and that's why we require capacitor. So combinedly transistor and capacitor is going to have our data. But in static RAM there is no capacitor, it is only set of transistors. So सबसे पहले कैपेसिटर क्यों नहीं है? अगर डेटा को थोड़े लंबे टाइम तक स्टोर करना है तो आपको कैपेसिटर चाहिए, क्योंकि ट्रांजिस्टर से करंट जो है वो लीक होगा. लेकिन कैश मेमोरी में हमें डेटा लंबे टाइम तक रखना नहीं पड़ेगा. दैट्स व्हाई वी डोंट नीड कैपेसिटर देयर. क्यों? बिकॉज प्रोसेसर जो है वो काफी जल्दी काम करता है. तो कैश मेमोरी के अंदर जो डेटा है उस डेटा पे प्रोसेसर जल्दी काम खत्म कर लेगा, देन आपको वो डेटा की जरूरत नहीं होगी. That's why we do not need capacitor in cache. Another thing, even cache memories are not that much larger compared to your RAM. हम RAM की बात करें 2GB, 4GB, 8GB, 16GB RAM हम डालते हैं, लेकिन इतनी बड़ी कैश मेमोरी नहीं होती. Because even we do not require that size of cache memory. No doubt, if you increase your cache memory size, then it is drastically going to affect the speed of your processor also. Processor उतना जल्दी काम कर पाएगा. But static RAMs, cache memories, are costlier compared to DRAMs. सिंपल रैम जो है उससे कैश मेमोरी जो है वो काफ़ी ज़्यादा कॉस्टली होती है. एंड दैट्स व्हाई you can see L1, L2, L3 cache memories like let's say 1 MB or 2 MB or 6 MB size of cache memory in a processor. So the hierarchy that we create, processor, cache memory, RAM, and then hard disk, this entire hierarchy is to fill those gaps between speeds of different hardwares. Okay, and your data will flow through this hierarchy from hard disk to processor and processor to hard disk back, and that's how your system works. Okay, well, any kind of question till now? Any question at this point of time? Yeah, okay. Let me have a look at. Okay, Jay is saying, remember computer, no. Yeah. Unless you have small GBs RAM, then your some software will take such time to be started. So what I believe that you want to share, Jay, is if you have less amount of RAM, then some of the softwares will take longer time to be started, right? That's what I get from your statement. Well, that happens because look, your data which is there, अगर आप सॉफ्टवेयर की बात करो या फिर आपके कोई फाइल की बात करो, everything is there in your hard disk. ओके, आपने सॉफ्टवेयर इंस्टॉल किया तो वो हार्ड डिस्क में इंस्टॉल होता है. आप अपनी मूवी, सॉन्ग्स, रिपोर्ट्स, प्रोग्राम्स, फाइल सेव करते हो तो वो भी हार्ड डिस्क में जाता है, बिकॉज हार्ड डिस्क इज द सेकेंडरी डिवाइस which is going to store your data for a longer period of time. Now we know the hierarchy. हार्ड डिस्क में से रैम में आएगा, रैम से कैश मेमोरी में जाएगा और कैश मेमोरी से प्रोसेसर को डेटा मिलेगा. दैट्स द फ्लो. अब रैम जितनी बड़ी होगी उतना ज्यादा डेटा वो स्टोर कर पाएगी. ठीक है, अगर रैम के पास ज्यादा डेटा है तो डायरेक्ट रैम से ही वो डेटा मिल जाएगा प्रोसेसर को, उसे हार्ड डिस्क रीड करने नहीं जाना पड़ेगा. सो अगर रैम कम है तो हमने कम डेटा लिया, तो जब प्रोसेसर अपना काम खत्म कर लेगा और उसको जब नया डेटा चाहिए होगा वो फिर से रीड करने जाएगा हार्ड डिस्क के पास, एंड इट विल टेक टाइम. लेकिन अगर रैम बड़ी है तो आपने ज्यादा डेटा रीड करके रख लिया रैम के अंदर, तो वो ज्यादा डेटा है, ज्यादा काम प्रोसेसर लंबे टाइम तक कर सकेगा. देन इट विल नीड न्यू डेटा, विच मीन्स अगर रैम के पास से डेटा मिलता है तो वो कंपैरेटिवली फास्टर है. अब होता क्या है, मान लो कि आपके पास 1 GB रैम है ओनली. आप जब पीसी स्टार्ट करते हो तो शायद 500 MB तो ऑपरेटिंग सिस्टम ने खुद ही खा लिया, बिकॉज ऑपरेटिंग सिस्टम इज अगेन अ सॉफ्टवेयर. वो हार्ड डिस्क में इंस्टॉल हुआ, लेकिन हम पीसी स्टार्ट करते हैं तो सबसे पहले ऑपरेटिंग सिस्टम रैम में लोड होता है, क्योंकि ऑपरेटिंग सिस्टम इज अ प्रोग्राम विच इज गोइंग टू रन कंटिन्यूअसली इन अ बैकएंड. तो प्रोसेसर को जो ऑपरेटिंग सिस्टम का कोड चाहिए वो तो रैम में आ गया. अब आपके पास बची 500 MB. अब वो बाकी की 500 MB में मान लो कि आप मूवी देख रहे हो, एक फुल HD मूवी डबल क्लिक करके आपने स्टार्ट किया, तो वो मूवी रन करने के लिए सबसे पहले आपका एक मीडिया प्लेयर सॉफ्टवेयर जो है वो स्टार्ट होगा, राइट? अगर सॉफ्टवेयर स्टार्ट होता है, 500 MB ऑलरेडी ऑपरेटिंग सिस्टम खा गया, 100 MB का शायद आपका वो सॉफ्टवेयर खा जाएगा, VLC प्लेयर मान लो फॉर एग्जांपल। तो अब बच गए आपके पास 400 MB। आपकी फुल HD मूवी जो है 1 GB की है, तो वो पूरा मूवी जो है आप रैम में लोड नहीं कर पाओगे, बिकॉज रैम में आपके पास सिर्फ 400 MB जगह खाली है। अब कंप्यूटर क्या करेगा, वो 1 GB मूवी जो है उसमें से स्टार्टिंग के 400 MB रैम में लोड करेगा, सो आपकी मूवी एटलीस्ट स्टार्ट हो पाए, आप देख पाओ उसको। अब प्रोसेसर जो है वो आपकी मूवी को रन करता है, आप मूवी देख रहे हो। नाउ इन बैक एंड वो 400 में से कुछ इस तरह से काम होगा कि पहले 100 MB का मूवी प्ले हो गया, उसकी ज़रूरत नहीं है, तो उसको हटा के 400 के बाद नेक्स्ट 100 MB जो है वो रैम में आ जाएंगे। एक्सक्यूज मी। सो दैट्स हाउ योर मूवी इज बीइंग प्लेइंग। आपको लगता है कि चलो मेरा मूवी अच्छे से चल रहा है, लेकिन अब आपको ये लगा कि अरे यार ये आधा घंटा नहीं देखना, मुझे डायरेक्ट जंप करना है नेक्स्ट आवर पे। आप जैसे ही वो सिक स्लाइडर जो है उस पर क्लिक करके जैसे ही आप जंप करते हो नेक्स्ट टाइम पे, वो डायरेक्टली प्ले नहीं करता, बिकॉज वो डेटा रैम में है ही नहीं, राइट? आपने जो पार्ट मूवी का देखना है वहां पे आपने क्लिक किया, देन इट लोड्स दैट पार्ट फ्रॉम हार्ड डिस्क टू रैम, रैम के बाद वो जाएगा प्रोसेसर के पास, एंड देन इट स्टार्ट्स प्लेइंग। दिस इज व्हाट हैपेंस इन बैकएंड। Okay, so Jay, if I think I have given your answer. Venus is saying it converts the binary language. Well, everything is in binary format inside your computer. It is only you that that gets your data in terms of text or video or audio, but inside the computer everything is binary. हार्ड डिस्क के अंदर भी बाइनरी में है, रैम के पास भी बाइनरी में है, प्रोसेसर भी बाइनरी ही परफॉर्म कर रहा है, ठीक है? Okay, Jay is also asking, in pen drive, why copy paste speed is not more than cut paste? Not only in pen drive, even if you check copy paste and cut paste speed in hard disk or pen drive or any other device, that will have a different speed. कॉपी पेस्ट जो है वो कॉपी जनरेट करता है, ओरिजिनल जैसे है वैसे ही रहने देगा। बट कट पेस्ट जो है वो क्या करेगा, कट पेस्ट एक्चुअली पहले कॉपी बनाएगा, अब एक फाइल की कॉपी खत्म हो जाने के बाद वो ओरिजिनल फाइल को डिलीट करने जाएगा। सो दैट्स द एक्स्ट्रा प्रोसेस योर कंप्यूटर नीड्स टू परफॉर्म व्हाइल यू कट एंड पेस्ट समथिंग। तो वो एक्स्ट्रा प्रोसेस जो है उसको एक्स्ट्रा टाइम भी चाहिए, दैट्स व्हाई कट पेस्ट रिक्वायर्स मोर टाइम कंपेयर्ड टू कॉपी पेस्ट। ओके, yeah, Venus is saying same thing happens in phone. Yeah, almost phone is nothing but a system, kind of a computer system. हम उसको फोन, इसको लैपटॉप, डेस्कटॉप अलग मानते हैं क्योंकि हर एक के पास डिफरेंट कैपेबिलिटी है काम करने की, लेकिन काम तो वो इसी तरह से करते हैं। फोन के पास भी उसका प्रोसेसर है, फोन के पास भी उसकी रैम है, फोन के पास भी उसकी सेकेंडरी स्टोरेज डिवाइस है। ओके, well, so let's have a look at next video now. Let me give you the link. So have a look at this video. This video talks about how hard disk works. Okay, hard disk कैसे काम करता है आपको ये समझ में आएगा। We will also see what is SSD, but अभी के लिए hard disk समझ लो। So go through that video And after that video, we'll again go for discussion phase here. It is again a 5-minute video, so have a look at that video and then we will discuss. Once you complete that video, just update your status in a chat box. So we will start discussion here. Well, Dhaval is asking what is MBR and GPT. Look, MBR is master boot record, and GPT is something guide partition table or something. Okay, those two are used inside your hard disk. Master boot record, so from where you are going to boot your system. Boot means the first thing that you are going to load inside your RAM, operating system. अब operating system कहाँ पे है वो master boot record से पता चलेगा आपको. And guide partition table is something related to partitions that you create inside your hard disk, and it records everything inside that table. Okay. So everyone done with this video? Yeah, so let me explain this part, okay, very quickly. So your hard disk looks something like this. If you physically open your hard disk, then internally it has this kind of structure, and it is going to have number of disks inside it. All these disks are electromagnetic disks, which is going to store your data. And on all the disks, you have a small, very small portions where you are going to store your data in terms of electromagnetic field directions, and those directions are interpreted as either 0 or 1. Okay. Well, so these are the heads that you see here. Along with your disk, you have the heads. Those heads are going to read or write your data in that small portion of your disk. So if we consider these are the small portions, then inside that we are going to have the directions, electromagnetic directions. And using those directions, we interpret that as either 0 or 1. Okay. If direction is right side, consider it 0. Direction is left side, consider it 1, and so on. So every head is going to have this electromagnetic field generator, which is going to generate that electromagnetic field enough to change that direction inside your disk. So North Pole and South Pole, something like that. Okay. So that's how your data will be stored. And separately, you will have field reader, electromagnetic field reader, which is going to read your data based on the direction of the magnetic field. So that's how your head of hard disk works, right? So at the end, you are going to have everything as zeros and ones. Now, how do we interpret those data? So a sequence of zeros and ones is going to be interpreted as a data. So how do we maintain that thing? So we store a character, any character, in 1 byte of memory. Now either 0 or 1 will require 1 bit. Okay, either it is 0 or 1, it requires 1 bit. Now when we combine 8 bits, we will have 1 byte. So a sequence of 8, either zeros or ones, is going to give you a particular character. That's how we interpret that data. So when this sequence has been read from the hard disk, we consider it A. If this is the sequence, we say it's a small a. If this is the sequence of zeros and ones, we consider it B, and so on. Now this is just an example. That's how everything works. So like characters, everything has been converted to the sequence of zeros and ones. maybe not a single byte, but maybe with longer or more than 1 bytes also. So even your image, we can say, can be stored with zeros and ones. Now, how? Well, image is created using pixels, right? That's why we have megapixel resolution. So image is created using pixels, and every pixel in an image does have a color intensity to create your image. And those color intensity we can store in kind of some kind of numbers, and numbers can at the end be converted to the binary number 0 and 1. So that's how images are stored inside your secondary device or the storage device. And when we talk about 1 megabyte image, that's the size of your image, then it is actually going to have these many bits required to store your image. So these many bits are going to be occupied within your hard disk or whatever secondary device you use. And that's why we have a size of our secondary devices also, maybe 1 TB hard disk, 500 GB hard disk, and so on, right? So that's how hard disk works. Initially, a very large size of hard disk was having a very less amount of space, but when technology improves, we were able to reduce the size of a physical size of a hard disk, and we were able to store more data inside that, right? And that's what this video talks about. And it also talks about different ways of storing data. I mean, storing data and improving the throughput of hard disk. So that's how hard disk works. Now let me give you one more video link for hard disk. You can have a look at this video later on. I don't say that you see this video right now, okay? But just a minute. You can see this video later on. This is also about how hard disk works, okay? And you can try to understand what that video explains about hard disk. Well, so this is something related to hard disk. Now, nowadays, technology has improved a lot, and we do have SSDs also, solid state drives. So let us have a look at video related to SSD now. So second link I have posted. Go and see that video first, and then we'll come back in this meeting and discuss about that thing. Okay, so this is the video. Have a look at that video, and then we'll discuss how SSDs work. Oh, sorry, I forgot to unmute myself. Wait. So let me again explain everything. Look, a 1 TB of VNAND SSD can store a full HD video data which can run up to 3 weeks. That's what they say. But if you want to have a look at the internal structure of that chip SSD, then we need to go up to the microscopic level of that thing. And if you look at the single unit inside that which can store your data, then that unit is called charge trap flash. It's a flash memory which can trap a charge. Charge means electrons. It is going to trap electrons inside it. So every charge trap flash has a different levels of trapping the electrons inside it. So those levels are going to range from 000 to 111. Okay, 000 to 111, 3-bit sequence of zeros and ones, which actually describes 7 different levels. Okay, it is going to describe 7 different levels of electron. So a single unit of charge trap flash can store 7 different levels of electrons. So it is capable of storing 7 different data. A single charge trap flash, right? And when you store electrons inside that thing, it is going to trap it inside for a longer period of time, so you can store your data for a longer time. Now, when you don't want it to be there, explicitly, electronically, you force those electrons and you remove those electrons from that place. So you make it empty again. So that same charge trap flash can be used to store another data. Well, that is the single unit. Now inside that SSD, you have total 100 layers of this kind of charge trap flash. Those 100 layers, each layer has 40,000 columns inside it, and each column has 50,000 rows. So it's a 3D structure now. 40,000 column, 50,000 rows, and such rows and columns creates one layer. We have 100 of these kind of layers. So just imagine what amount of charge trap flash you have here. And those charge trap flashes are going to store your data. So to just understand that thing, you consider that you have an Excel spreadsheet here, which has rows and columns. Okay, so 50,000 rows, 40,000 columns, and each cell can store your data in a range from 0 to 7, 000 to 111. Those are the 7 different layers. So you can store 0 to 7, any number inside this cell. Now you have one sheet of this kind. Now what you need to do is have 100 sheets of these kind of data, and that's going to be your entire chip or entire SSD. Now how do you read and write data? So for that, to select a layer, you have control gate selectors, and to select a column, you do have bit line selector. So using that, you select a particular line and then you read that entire line. You'll have your data from that SSD. Well, so that's how this VNAND SSDs work. Okay. So any other query or question at this point of time? Okay. Now let me give you one more link as I promised. There are different SSDs available. There are NVMe SSDs, there are M2 SSDs, there are mSATA SSDs and all. So the next link that you can see on a chat box, it explains all these 3 different kind of SSDs and where you can use which one, okay? So you may go for this video later. Now, before I stop this recording, because we don't want to have unnecessary lengthy recorded video. So I'm going to stop this recording here. But before I stop that record, please post your enrollment number in the chat box. I'm going to extract that number for your attendance. As long as video is being recorded, your chat is also being recorded. Don't write your name. It is already there as a person name. Just give your enrollment number. So this chat will be recorded and I'll extract your numbers to fill your attendance later. So very quickly, just post your enrollment number. Still, there are few students who have not posted their numbers yet. One last call. अगर आपने post नहीं किया अपना number, just post it in a chat box. Then I'm going to stop this recording. Okay, so I'm going to stop this recording now. I've posted one more link in a chat box, so go through that video link. Try to understand that video, and later on you may search by yourself. Now just have a curiosity to learn something new. Okay, now we all will be here till the end of this session. I'm going to be here till the end of this session, so at any point of time you have any kind of query or question, we will discuss that thing here. Okay, so go and have a look at that video. I'm going to stop this recording, and once you are done with that video, we will discuss that and that process also. Okay, so let me close this recording now.